What is next? Now, after getting your copper elbow, all this your elbow, like I said, all this your refrigerant pipe doesn't require much elbow like that. Are you getting me? So there's some instances whereby it will require elbow based on it's already passing through a wall, and I don't want to bend too much of my pipe in the wall. Now I'll just request for an elbow. How did I request for an elbow? The elbow coming from the top for these two pipes is 1-1, and the one that will make it curve when it's coming outside of that of the building, making 1. So I make it 2-2 now. So sorry for that. So after that, we are done with our refrigerant pipe, and we are done with our elbow. There are sometimes, remember, there are sometimes, not every time you tend to calculate elbow. There are sometimes whereby in your build-up rate as a QS, you make some allowance. What that means? Allowance for some little accessories that it might be later be used. Maybe you just allow for a certain percentage, maybe 5% of the cost, while will now be incurred in your build-up rate. Are you there? Now, after that, we've already calculated for Y branch last week. You've all this your tone, threaded rod, flat bar, adjust your accessories. I mean your accessories as in your fixing accessories just to hold the duct, which that one has already been calculated last week. This your armor flex. The total length of your refrigerant pipe is also the total length of your armor flex. If your armor flex is 100 meter, if your refrigerant pipe is 100 meter, now remember that we have different sizes of refrigerant pipe, and each size of that refrigerant pipe has its own each sizes of what of armor flex. Let's not forget that one armor flex is 2 meter. This 2 meter or 1.8. So if you're like now, look at this one, 9.5 mm diameter. It has for a 2 meter. It will have its own armor flex on this case. That is to say, its own armor flex will be what for a 2 meter. Does anyone knows? I hope everyone understand what I mean by armor flex. Are we there?
Yes, sir. I think it will not be everybody, but most.
Okay. Armor flex is just like a tube. Is a common tube whereby you just want to put something inside. It's just like armor flex is used for protecting your refrigerant pipe from corrosion. So let me just try and display. This is what I mean by armor flex. So this is what they called armor flex now. Is a tube which is not that expensive. Based on the type, you see the one of 1.4. Based on the type of the armor flex you want. So this is what they called armor flex. Can you see my thing? So this armor flex has its own sizes too. If you have a pipe of 1/2 inch, you can't expect a pipe of half-inch to enter a pipe of a pipe of 3/4. It's not possible. So if you are buying half-inch, it shows that the amount of flex will be buying will be a bit bigger than than your normal to refrigerant pipe. And we have the different brand of refrigerant pipe. We have the mostly consultants do recommend using South African brand of the refrigerant pipe. Are you all there with me? So like I said, we have the drainage above the ground or below the ground. We have the mechanical. Now we've already taken care of the mechanical part on the VRF now. Now we just want to go through the drainage below the ground, which is the what? Is the condensate pipe in this case. So let me just there and display my screen. Now, let's not forget that as your pipe goes, there will also be a sleeve, something called sleeve. In mechanical, we call it pipe. This is why we call it pipe is because water substance, a liquid substance pass through it. But when a solid substance pass through a pipe, they don't call it a pipe. They call it a sleeve. Now, we have a sleeve, like I have said. Now, your total length of your refrigerant pipe will be equal to the total length of your pipe being recommended for your sleeve. And let's not forget that your refrigerant pipe leading to your condensate, leading to your outdoor unit will not have a sleeve because it is inside the wall or inside the slab. You have your sleeve in this case. And sometimes some people tell you that maybe it is ceiling, it is in the ceiling, so we don't really need a sleeve in this case, except when it's in the wall. Now that it's in the wall, you have to take care of your sleeve, which is the pipe. We are being told to use 75 mm sleeve, 75 mm UPVC pipe, just your normal pipe. I'm not saying you should buy an expensive pipe. This is just to protect your condensate, your refrigerant pipe, and your flexible cable in this case. Now, I just have my 75 mm UPVC pipe in this case now. So how many length are we using? You get? So what is the total length of your condensate, your pipe we calculated earlier? 42 plus 6 meters. And let's not forget that a pipe is a single pipe is 2.7 meters. So if you divide 48 by 2.7, it will give you 18 length. But in mechanical, in this place, let's call it meter, which is 48 meters. Now, if you're also talking about your condensate drain pipe too, your condensate drain pipe will be the one to drain your water out of the building. Sometimes we tend to use something called hose, but that hose is not reliable because at any time it can got burst, and when it got burst, it will now start dropping water at that point of where it's being punctured. But when you use your UPVC pipe as your condensate drain pipe, it will be more safer than that. Now I just have my 25 UPVC pipe. Like I said, total length of your
because it's too slow.
condensate drain pipe.
This thing now.
The total length of your condensate drain pipe is equivalent to the total length of your what? Refrigerant pipe. Are you getting me? Now, we have sockets. Like I said, at every 3 meters, there will surely be a socket. In electrical, we call it a coupler. You can also call it a coupler, but in mechanical, they call it a socket. Now, we have at everywhere you are joining two pipe, there will surely be a socket in this case. So if you divide your pipe, how many socket do we require? Your total length of your pipe is 2.7. Divide the total length of your pipe, which is 48 by 2.7. We give you the numbers of your socket you want, both for 25 mm and what 75 mm. Let's not forget that this 75 mm is for your sleeve. Sometimes you might not use this your UPVC pipe as your sleeve to cage your condensate, to cage your both condensate drain pipe and the refrigerant pipe. Sometimes you tend to use a flexible tube in this case against you using your condensate, your UPVC pipe as your sleeve. So you tend to calculate your elbow in this case. So all these one are just something that can be calculated based on how you want to run in the building. Are you getting my explanation? Now, we've already taken care of drainage. Let's not forget last week, or is it 2 weeks ago, we talked about our single unit system, where I was able to break down how to calculate your drainage below the ground, your mechanical aspect of the HVAC, and your electrical aspect in this case now. But in VRF now, the type of cable you are using in this case will be above 2.5 mm flexible cable based on the capacity. You can't compare a single unit. Nancy. Okay, Malo, thank you. You can't compare a single unit with just a capacity of 1.5 horsepower at the rate of 3.61 to something kilowatts in this case. And now compare it with a capacity of 11.5 kilowatts, and you still want to use the same cable. No, it's not possible. In this case now, you'll be using 4 mm flexible cable, 4 core flexible, 4 mm by 4 core flexible cable will be used in this case. Now, sorry to say, you can see that there's, like I said earlier, engineers will always subject you to use their own format. So based on the company you are working with, they will tell you this is what you have been doing. So that was why you are seeing a BEME. So I'm sorry for that. Next time, maybe before we wrap up this thing, I will send us a price bill. But actually, I've sent an empty bill already. I mean, a dumpy bill, whereby we can just go through it, which will help us. Now, let's not forget that we have something called electrical. And in this electrical now, there's something called isolator. Apart from your cable turning from your ceiling cassette or concealed unit down to your outdoor unit. But you remember that this your outdoor unit, you will also have something called isolator. Isolator is just like you are working in a substation, and in that substation, you want to make a part of the substation functioning while the other parts not to be functioning based on the maintenance. Now, you use something called isolator. Isolator means you just want to bridge the gap of what? Electricity. One part, immediately you have that isolator, there won't be light at the area whereby you are presently working. But that one, it won't be calculated under mechanical. It will be calculated under the major electrical. But now, in this present VRF now, we have to calculate the electrical, but not the major electrical. As in, I'm talking about the cable that will be connected together. Because, like I said earlier, VRF, you might have 6 ceiling concealed units being connected to just one outdoor unit outside. Unlike our single units that whereby you have one indoor unit, you have one outdoor unit. If you have 16 indoor units, you have 16 outdoor units. But in ceiling cases, it's not being done in that way. Like this VRF now, all this your ceiling concealed or your ceiling cassette, we just have one outdoor unit while everything will now be interconnected as one, and it will not be linked back to your what? Your outdoor unit. Okay, let me give us a picture of the indoor unit I'm trying to explain in this case, so that it won't be a new thing to us. Okay, sorry for that. Now look at this picture I projected now. This is your ceiling cassette now. This is our ceiling cassette at a particular aux power and at a particular kilowatt. Are you getting me? And at a particular load. Now, in this case now, you can see this black stuff is where our refrigerant pipe is coming from. Like I said earlier, sometimes you might have 2 refrigerant pipe, sometimes have 3 refrigerant pipe. We have the liquid, we have the gas, and we have the aux. But when you have 2 refrigerant pipe, you show that you have the liquid and you have the gas. But when it is 3, you have the third one as the hot suction. Are we getting my explanation?
Yes, sir.
Now, this is our ceiling cassette, and all these black aspects are the what? Are the refrigerant pipe linking from one ceiling cassette to another ceiling cassette or concealed unit. Are you getting me? Now, we are just left with the electrical part now. But in this drawing, they didn't give us where the positioning of our AC. So I calculated the electrical part under the AC, under the electrical part, not the AC. But there are some cases whereby your AC will have your electrical part. So let's just do a little calculation here, in this case now, you have, okay, let me down project my this thing. Sorry for that. Now, at every FCU, that's fan call unit, there will surely be an electrical electrical cable. Now, like I said, in our refrigerant pipe now, we have 42 meters for all these pipe linking to each other. We have 42 meters. But let's not forget that this cable, one cable is meant for this AC. But it will just be like you have a lighting point. At every interval, there will be a cable that will be dropping in this case. Now, we have our 42 meters as our length of our refrigerant pipe here. And we have 6 meters based on, this one is on the ground floor, on the first floor. The height of a building is 3 meters. First floor, 3 meters. Ground floor is 3 meters. Now, it will not be 6 meters. That's 6 plus 42. We have what? We have 48. And let's not forget that at every point, there will be a termination. And let's not forget that this cable is a flexible cable, and it is what? 4 core by 4 mm cable. It depends on what is being recommended. Some electrical will tell you 4 core by 6 mm cable. Now, if it is 1 core by 4 mm cable, it shows that you have 4 runs. What do I mean by 4 runs? You use 4 numbers of cables. Let's assume that, I'm not assuming, we've already calculated 6 meters at the height, 42 meters internally, making 48. Let's now allow for termination. Termination means at every fan coil unit, 1 meter will be dropping based on our headroom. Now we have 6 meters, we have 1 meter, and we have 6 numbers of fan coil units. We have 1, 2, 3, 4. That's 6 meters plus 42 making 48. 48 plus 6 making 54 meters. And let's not forget that we didn't know the distance at where our outdoor unit will be. Like the picture I shown to you, we didn't know where it will be. But let's just allow for, okay, extra 6 meters away from the building will be on the safer side. That's 54 plus 6. We have a total length of 60 meters of your cable. Now, in this 60 meters, if you are being told that it is 1 core by 4 mm, so it shows that 60 meters times 4 places, making 240 meters. But if you are being told that the cable you are using is 4 core by 4 mm, it shows that in one cable, you'll be seeing 4 cables being joined together as one. Are you getting? Now, in this case, now we have 60 meters of 4 core by 6 mm cable. In this case now. Now, we've already calculated for cable. Now, what other accessories are you using again? Let's not forget that this your cable too, we also have a sleeve. I mean by a sleeve in this case now. But that sleeve, I won't calculate it as a sleeve because we've already have a 75 mm sleeve in this case now. That's 75 mm cable. We have our condensate pipe passing through it. We have our refrigerant pipe passing through it. And we have our what? Our electrical cable passing through it. So I won't calculate for any sleeve here in this case now. But the reason why I'm not calculating any sleeve for it because we have all this conduit pipe at 25 and 20. But sometimes you can also calculate a conduit pipe because 6 mm will still pass through that your this 6 mm cable or 4 mm cable can still pass through your 25 mm. I mean by 25 mm conduit pipe. All these are normal pipe that is being used for conduit. Now we've already have 60 meter. It shows that our 25 mm conduit piping, control 25 mm conduit piping, we have a 60 meter which will be used for that for cable, flexible cable. And let's not forget, at every interval of your pipe, you have something called your joining coupler. In electrical, we call it a coupler. In mechanical, we call it a socket. All this one will be a build-up rate in your for your conduit pipe. Because I can't be saying I want to use 10. I can't say I can't say I want to use a 10 numbers of joining coupler now. But in your build up rate, you'll have factor it there that okay, I have 60 meter at every so meter, I'll be using so coupler. It will have been factored in your build up rate alongside with all your accessories needed. Is it your hanger, this, and the lines, your hanger and the lines, everything will be factored in your build up rate. Maybe before the end of this thing, I'll try and just put us through on how to build up rates for mechanical and electrical. Or like the BEME aspect that engineer doesn't know how to build up rates. They will just use percentage. Okay, my AC is 10,000 naira, mark it up with 20%. Labor, just allow 20% of the material, which is not visible. Any question? Any question, please? I hope I've been able to pass a message across. Any question, please?
No question, sir.
Okay, if there's no question, will you say that everything has been explaining? You understood everything? Is that what you said? Is that what you mean?
Yes, sir. Yes, sir. To an extent, we have I've gotten.
My DM is open. You can ask me question anytime. You have my number. So, any other person? Mr. Sholanke.
Yes, I can hear you. I think I'm good as well. I'm actually following up and I'm getting it little bit by bit. Thank you.
In as much as I've already sent the material to Mr. Jamil, so it should get down to you.
And I think we implore us to, if you are going through the materials again and again, if there's any aspect that we don't understand, we can actually reach out to our tutors through DM. Like he just said, to everyone who is on this tutorial this evening. Thank you.
Yeah. So, any other question before we now move to the main domain of today? That's the fire hydrant system, whereby we're talking about the sprinkler system, OZ system, and the external fire hydrant. Any question? I can see my friend here, Madam Sarah. I can see one of my colleagues, Mr. Toby. Can see some Jacto Studio. Any question, please? Madam Eileen.
Good evening, everyone. Good evening.
Good evening, ma.
So sorry that I've not been following up. I've been busy with green building program. So sorry, guys. I just said let me start today, and I think the class is very interesting. I love every bit of the explanation. So, and the only observation there is this civil engineers trying to force us to do their will, and I think we'll work on that to see how our bill of quantity will be recognized in all the industry, because that will be acceptable. With what civil engineers are doing is not acceptable, but we just need to play along with them for some time to see how our president from the top we work and see that we move it to the Senate and it is approved that civil should face their structural work design while we do the costing. That would be more better, but I must say it's recommendable. So if you have this one and you find yourself in the civil sector, this would be very best for you. Then when you find yourself in the QS sector, you can still switch. So it's a win-win game. Sure. We are not afraid of anything. Anywhere you put a QS there, he or she must always adjust and adapt to any situation. So kudos to every one of us. Thank you, guys.
You're welcome.
Thank you very much, Sarah. Thank you for joining us. We really appreciate it, and thank you for that observation. Thank you.
So, so if there's no question, so let's just run through the topic of the day. We'll be talking about the fire hydrant system. What did I mean by fire hydrant system? We'll be talking about the fire fighting installation. Now, let's not forget that. Let's not forget that. Let's not forget that a building without a fire protection is like a building subjected to, how will I say, fire outbreak. I'm not saying that we are praying that our building should call fire one day, but there are some things we need to put into place. Apart from your fire alarm system, that will be ELV, that's extra low voltage, that we'll be discussing under the electrical part. But now we'll be talking about fire fighting system. We will talk about the fire hydrant, hose reel system, and we'll now be talking about your sprinkler system. Under sprinkler system, we're talking about the wet riser and the dry riser. Now, let's move to my, let me just show you some couple of pictures and let's see how it goes. Now, I know a couple of us we will have seen something like this in the building. Are we sure? This is what we call sprinkler head. Are you there? Has any one of us seen this one in any of our building? No, it might not be in your own building, but maybe you just get to a place, you just look at your ceiling, you are seeing something like a small drop. I'm not talking about the smoke detector or heat detector, but a sprinkler head like this.
Yeah, I've seen it before. I think that's a Koyi, a building that is being built by Elalan. So we went on a site visit there. So they showed us. I've seen it.
Okay, now this is a sprinkler system. This sprinkler system has its own diameter it can cover in a particular section. and it is usually being under pressure. Let's not forget that when a design is being done under electrical, we have the radial system and we have the what? And the ring system. Likewise, we also have it in our fire hydrant system, whereby we have our ring system and have a radial system. But most design that is being done is usually being in ring system because we want to put our what? We want to put our pressure, our pipe on pressure. And let's not forget one thing. We have different pipe. I'm not talking about my steel pipe. I'm talking about black steel pipe. Sometimes some will, based on what is going on now, some might recommended HDPE pipe. That's high density pipe. HDPE is not being used as a common pipe. It's not a pipe you just get to the market and say, I want to buy HDPE pipe. It's a pipe that is being used for fire hydrant. If you're not using your black steel pipe, you can use your HDPE pipe. It's not a pipe and it's very costlier than your normal pipe. Now, I'll be talking about our sprinkler system. This sprinkler system is usually automatic. What do I mean by automatic? When there's fire outbreak, immediately you put on your fire pump straight away and water rush into the line. Your sprinkler system be pop up, which is this sprinkler head. Now we have pipes. We have different type of pipe. We have the Schedule 40 and the Schedule 80. Now, and let's not forget that this our pipe, we have two type of pipes. We have the seamless pipe. I hope you are jotting because this is not part of what is inside my. We have the seamless pipe and we have the seamed pipe. Now, this seamless pipe has its own. This seam pipe and seamless pipe has a pressure both of them can withstand. Now, hold on, please. I'm just trying to open my jotting book so that you understand what I'm trying to explain. Now, we have this seam pipe and we have this seamless pipe. This seam pipe can be put on a bar of 4 to 7 bar. 4 to 7 bar. While your seamless pipe can be put on a bar of 4 to 9 bar. What did I mean for 4 to 9 bar? Now, if you